Okay, so what you've been given out here is argon gas, and as you can see, this argon has a pressure of 19.8 atmospheres and volume of 50 liters, and the temperature given to you is 19 degrees centigrade. Of course, you have to change this 19 degrees centigrade into Kelvin. Okay, so it's 292.15 Kelvin if you add 273.15 to 19. And what it tells you is that this gas is allowed to expand, and when it expands to a pressure of 0.974 atmospheres, and it's asking you what the volume is, and the temperature, what they say is constant, implying that T2 would be equal to T1. Okay, so the equation that you need to use here is the combined gas equation, which is given by P1 V1 by T1 is equal to P2 V2 by T2. Okay, and so if you go forth on this, you'll see that you can actually cancel out P1 and V1, T1 and T2, because they're constant, and so you'd be left with simply Boyle's law, which is P1 V1 is equal to P2 V2. So now you just need to plug in the quantities. Okay, so if you see, P1 is actually 19.8 atmospheres, and then V1 is 50 liters, and P2 is 0.974 atmospheres. Okay, so we're going to go ahead and plug those quantities in, which is going to be 19.8 atmospheres for P1, V2 is 50.0 liters, P2 is 0.974 atmospheres, and V2 is what you're supposed to find out. So if you rearrange this equation, you'll get V2 is equal to 19.8 atmospheres times 50.0 liters divided by 0.974 atmospheres, which is equal to, so you can very easily cancel out atmospheres and atmospheres, and what you're going to end up with is 1016 point something liters. That should be 1016.43 liters, and you can calculate for significant figures. That's basically how you do this problem.